Okay, here we go. Number 13. It says angle of elevation, and you got to know that that means from a horizontal line. So everybody start by drawing a triangle with me. Draw a horizontal line. And now an angle of elevation goes up from there. So I can go like this. If you're a lefty, you might have gone from the other side. That's fine. All right. Now, how steep is that angle? Blah, 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 blah. 60 degrees. Oh, man, I made mine too small. I should probably make it steeper. So I'm going to make it more like that. And you're right, that means the other angle at the top is 30, but they aren't asking us for that, so I'm not going to write that in. I'm going to write in the 60. I'm going to write in the 300 feet away from the base. Do you think that's the height? No, because they're asking for the height, so the 300 must be this. Doesn't this look like a trig question in which I want to figure out this? All right. I'd say that cell phone needs to go up on my desk. Oh, texting your dad is not a reason. Put it on my desk, please. All right. Is it sine, cosine, or tangent? Tangent. Tangent of 60 equals what? Almost done. TOA is opposite over adjacent, and the opposite side's h. Over the adjacent side is 300. So there it is. Now I just have to use my calculator and figure out tan of 60 and times it by 300, and I got my answer. Okay? That's how you do that kind. You basically set yourself up a triangle. Make sure that when they say angle of elevation, you're going up from the horizontal versus the angle of depression means that you're going down. All right, moving on. A lot of these that are all the same. Here's one that's different. It's a real pain in the butt, which makes me think it's probably on the final. Paying attention? Good. All right, here we go, number 18. The Cerrito Lindo travels at the speed of 40 knots, which means nautical miles per hour, from Fort Lauderdale on a course of 65 degrees for 2 hours. All right, I better start drawing a picture. So I have this little dot, that's where I am, and I'm going to go at a course of 65 degrees. I'm going to make one of these little dealy bobs. Do you remember these? A course of 65 means like something like that. That means that this angle right here would be 65. Get that? Now, how long is that line? It's 40 knots times 2 hours makes 80 nautical miles. That line's 80. Then it changes to a course of 155 for 4 hours. So from this spot, I'm going to remake my little compass rose. And 155 means like something like that. And it does it for 4 hours, which is twice as long. So instead of being 80, it's going to be 160. And then I'm going to save some time by saying that if this is a total of 155 from here to here, then I did the math on it before. This ends up coming out to being a 90-degree angle in there. Once I know that's a 90-degree angle, then I know I've got a right triangle, and therefore I can use right triangle trig. All right. Now, this other side we could do by a squared plus b squared equals c squared, do that whole thing. Wouldn't it be handy if I knew this angle right in there? That's not 25. I think I know what you're saying. This part of the angle right here would be 25. Okay, but that angle right there would be found by doing, I need opposite and adjacent. Which one gives me that? Which one uses opposite and adjacent? So I need tangent of theta equals 160 over 80. That's the same as tangent theta equals 1/2. Write that down. Sorry, not 1/2, 2 over 1. So now you can use a calculator. Inverse tan, you'll know how many degrees that is. How many degrees is theta? 63.4. I'm going to round to 63 degrees. So that means this angle right here is 63. This angle was 65. 65 plus 63 makes 128. And that means I can figure out what that angle is. take 180 minus the 128. Somebody with the calculator, would you take 180 minus 128? Okay, so that's 52. Now, why do I care that that's 52? Because I'm gonna slide this down a little bit. Because okay, I need to figure out my bearing to get home. So from this little spot right here, I make another little compass rose, and I ask myself, if I was going to have to go this way, how many degrees is that? Would you agree that it's more than 180? Would you agree it's more than 270? Do you get how I'm going to have to figure out this little angle right here to say 270 plus that little angle? All right? That'll tell me my bearing. 270 plus something, it's going to be around 300-ish. All right? Well, if this is 52 right here, look at the triangle that gets formed right here. You get how if that one is 52, that this one has to be 90 minus the 52? In other words, it has to add up with the 52 to make a total of 90. So that makes it 38. And if that's 38, you take 270 plus the 38, makes 308. So your bearing, 308 degree bearing. And how long is this side right here? You can use a squared plus b squared equals c squared, or you could have used like a tangent thing. Let's see. It would actually be sine of theta. And I know how many degrees that is. That's 63 degrees. So sine of 63 is equal to opposite over hypotenuse. Opposite is 160 over hypotenuse. I don't know. And you could solve that. That's a tough one. That's definitely R3 level. There are no R4s on the test. My guess is it's probably on the test. Could be wrong. All right. Yes. If just think in the real world. From Fort Lauderdale. Good question. In fact, I think that the person who wrote this, because all the other problems we've ever done, it's been how do you get home? I mean, that's very practical, right? You're already out in the ocean and you want to set a course for home. Okay? But I'm afraid that you're right, that I can't slide this over because it's scrunched on here, but if they say from Fort Lauderdale, the rest of it's off the screen, so I can't tell, but I think you're right. If they are trying to say this bearing,
it says from Fort Lauderdale.
Yeah, I think you're right. I think you're right. I think I'm wrong on this 308. I'm glad you said that. Because it depends. I don't know what the test question is, first of all. I don't even know if it's on the test. But if it's on the test and it says from Fort Lauderdale to the boat, then it better be this one they're talking about, which would mean I would take this angle right here, which would mean I would take the whole all the way would be 180 minus the 52. So whatever 180 minus 52 is, would be that one. Let me think. Yep. So then I think it's 128. I'm glad you said that. All right. But I don't know which way it's going to be. Normally they say, how do you get home? Okay, but maybe they're like trying to send somebody out to that ship because it sank right there or something, and then you would go this way. All right, good point. Moving on. Solve for x in the given interval. All right, x is a number of degrees. Given that you have a calculator, this will be easy, but you don't have a secant button. Normally, you'd go inverse secant of x, but there's no such thing. What if I were to replace this secant x equals 2 with, flip it over and use its evil twin? What would that be? What's the evil twin of secant? Don't, please. All right. Evil twin of secant, cosine. And then I flip this over like that. You get that? Now you can use inverse trig. And I go inverse cosine of 1/2. And you can get your answer that way. Now just make sure it wants the answer between 0 and pi over 2. So let's say the answer comes up to 30 degrees or something. You wouldn't put that. You'd want it in radians. See, this is their way of asking for radians. Okay? Did you get 60 degrees on that one? Okay. So then you don't put 60 degrees. What's that in radians? Pi over 3. All right. That's how you do that kind. Here's another one. It's kind of like they're giving you a little clues. They said tangent's 13 over 15. Well, right there I know a lot. But all students take calc. What they're trying to tell me with this is that cosine is positive, which means I'm either here or here. Tangent being positive was going to either be here or here. Where do they overlap? Right there. So I have to be in that quadrant. So I'm in this quadrant, and I got this theta. And a tangent is opposite over adjacent, so that's a 13 over a 15. Could you figure out this side from that? Yes, you could. You'd have to take 15 squared plus 13 squared, and then take square root of that, and you get this nasty-looking number. Okay, let me think. Is this a 3, 4, 5? No, it's not. I don't know. Some nasty number, I guess. And now I get this nasty number. I'll call it N for nasty. And I want now the secant. Well, sine, cosine, and tangent, we have the SOHCAHTOA for. To remember the other one? SOHCAHTOA. That's correct. And if you want to just remember it this way, secant is the evil twin of cosine. And cosine is ka. So secant would be sha. So I want the hypotenuse over the adjacent. So it's the nasty number over the adjacent. 15. So whatever that nasty number is over 15 will be your answer. Okay? All right, some more kinds of problems that you need to know how to do. This one. Who can see what can factor out? Come on. Cosine. Everybody factor out the cosine. 2 sine minus 1. And then, since it's equal to 0, which is what you want to do, you want to set them equal to 0, either that's equal to 0 or that's equal to 0. So cosine x is equal to 0. You can use your big brain to figure out where cosine is the x part, right? Where is x equal to 0? Is it at this spot, this spot, this spot, or this spot? The spots where x is equal to 0 would be this spot and this spot. And that would be normally 90 and 270. But since we're in radians, it's going to be pi over 2. And what's this one down here? 3 pi over 2. All right, so that's this side. And then the other side of it over here is set that equal to 0. 2 sine x minus 1 equals 0. 2 sine x equals 1. Sine x equals 1/2. And then I got to find 2 answers for that, where all students take calc. Gives me a clue. Sine is positive here and here, so it's that and that. And one of them is 30 degrees, which is also known as pi over 6. And the other one over here, if this is 1/6 of a pi right here, then this one would be 5 pi over 6. That big angle. So, 1 answer, 2 answers, and a couple more answers over there. Man, complicated problems, but you're in a complicated class. This is not an easy class. All right, next one. Number 23, find all solutions. Same idea, except this one's a quadratic. And I think this is the one that they changed for you and said to make this plus into a minus 1. Do I remember that correctly? All right, everybody get to number 23 right now and change that to a minus 1. But the problem is, I think the intent was to make this thing factor, but it still doesn't factor. Maybe I wrote it wrong, but you tell me. If I replace the cosine with just an x, doesn't this come out to 4x squared minus x minus 1? And I don't think that factors. I'm pretty sure it doesn't. I played around with it last hour, and I can't find a way to factor. So I think the intent was to make this a number that would factor. So let's just mess with it until we find a number that would make it work. Can you guys think of a number that we could make that last thing so that it would factor? So let's use 4x and x. Could have been 2x and 2x. You think plus 3, minus 3? What do you think? You want it to be like this? That's really close, but that comes out to positive x, right? All right. Plus 3 minus 1, like that. There you go. And then what number do I need here then? Minus 3. All right, everybody, officially change this problem to be a minus 3 right there. And then it'll factor nice. Make that a minus 3. Then it'll factor nice. Then you'll get 2 answers. Just remember that at the end, you have to substitute cosine back in. So if you come out with like x is equal to 1, and so the answer would be negative 1, you want cosine x to equal negative 1, that kind of thing. Okay, 4x and x. We figured out that it was plus 3 and minus 1. You get that? All right, so now I substitute cosine back in. Be good, please. Cosine x minus 1 has to equal 0. So cosine x has to equal 1. And so can you solve that one from there? I think you can do that. Is cosine ever 1? Yeah, it is. Okay. So there's going to be 2 answers for that one. Then over here, I'd say 4 cosine x plus 3 has to equal 0. So 4 cosine x equals negative 3. So cosine x equals negative 3/4. And so then you got to use your inverse cosine calculator and figure out that one. All right, moral of the story, when you see ones like that, they're quadratics and you factor them. Once you're done factoring them, you can get your 2 sets of answers. All right, put that away. Oh, good. All right, moving on. All right, this one was a tricky one, and it reminded me of some graphing stuff. We're going to do a lot of graphing stuff tomorrow, so I don't want to try to, it took a long time, and I don't want to take that much time on this one. And we're going to do a lot of graphing stuff tomorrow. That starts like at number 30 when we do lots of graphing. So we can do this, though. Okay, transformations and the period and phase shift. All right. You remember when there's like a 4 on the inside? Does that make it 4 times wider? The stuff on the inside does not do what you'd expect. That 4 does not make it 4 times wider. It does what? 4 times narrower. Okay. This guy, do we trust him, and is it really 3 times taller? Yes. It makes my cosine graph 3 times taller. And last thing is this negative out front. That makes a flip. Is it an up-down flip or a left-right flip? Up-down flip. The stuff on the outside's an up-down. Okay, so if you're looking at this, for instance, that's up-down stuff. Stuff in there, that's left-right stuff. Okay? No. Nope. That would be if it was a stretch of some sort. All right, and the last thing on these is, no, it's not the last thing. The next thing is the period. The period is equal to 2 pi over b. Write this down. Next to problem 26. If your pencil is not moving, you're not doing what I asked. The important formula. Because by writing it, you hopefully remember it when the time comes. And if it's 2 pi over b, what did they tell me? Did they tell me the period? No, they told me b. What's b? 4. So I'd stick a 4 in there. So the period's 2 pi over 4. Can you reduce that? Pi over 2. So the period of this thing is pi over 2. Get how to do those? Very simple answer. And the last part, the phase shift. All right, the shift. First of all, I hope you could picture that the shift would be that thing. But when you're doing a phase shift, this is one kind of problem where it's a little more tricky. You can't just say, oh, the shift is right here. I need your attention. Put the coin away. Thank you. Up here, I have to factor that 3 out to be able to make this a phase shift. Remember how you take this and you factor the 3 out? The 3 comes out, and then what's inside is x and a minus. And then this is kind of tricky. You got to just think it through. It's not pi over 2. Because if I multiply 3 times this, I will get 3 pi over 2. I don't want that. Pi over, let's try 9. So then I get negative pi over 3. Close. 18 is correct. Okay, so then I take this times this, and again, I get pi over 6. So then, why did I do that? Because that's the phase shift right there. The phase shift is negative pi over 18. So you push, first you put it into that factored form, then you can see the phase shift. Okay. That's enough on that. Bunch more of the same kind of problem. They're asking about phase shifts, the period. On this one, what's the period? What's the period normally? Period 2 pi over b, right? 2 pi over 1, which would be 2 pi. All right. Okay. Well, if it's cotangent, first of all, we have to go back to what is cotangent's normal period. That's important to know. Tangent and cotangent have the same period, which is what? It's pi. It's not pi over 2, it's pi. So its period equals 2 pi normally, but this isn't normally, this is cotangent. So it'd be pi over b. What is the b term here? There's no b term, but there must be a 1. Okay, so it's pi over 1, which is pi. So what is the period of cotangent? Pi. But you do have to remember that pi, the period of tangent and cotangent, is different than all the other ones. All the other ones' period was 2 pi. All right. In order to sketch the graph of secant, it's convenient to first sketch the graph of whatever. Okay, I need just to remind you a little bit of the graphing stuff we're going to talk about tomorrow. Remember how on top of sine, another function rides on top like this? What function is that that's riding on top of sine? Cosecant. Okay. Do you remember how this one actually has asymptotes that run right along there? Right? Okay, so the one that rides on top of sine is cosecant. It's always the evil twins that go together. But tangent and cotangent aren't like that. They don't ride on top of each other like that. Tangent and cotangent are just totally different. So if I was going to have you remember the basic graphs, here's sine. And it goes, you'd need to know these basic ones. Pi, 2 pi, what's in there? Pi over 2, and this spot right there? 3 pi over 2. Okay, that's the basic tangent, or sorry, sine one. Here's the cosine one. Remember that? That's cosine. Makes a big U. Next two are tangent. That's tangent. And cotangent looks a lot like it, but its asymptotes are different. Here's cotangent. And instead of rising, it's always falling. Okay? Here's a question. Which function has the same asymptotes as cotangent? Well, it's not tangent, because that's asymptotes are over here. It must be one of those other ones that rides on top of something else, right? It would be the one that goes like this, right? The one that rides on top of sine, which would be what? Cosecant. So cosecant and cotangent have the same asymptotes. That would be a good test question. Don't know if it's on there or not, honestly. I'm purposely not looking because I don't want people to be like some person in here that goes up and says, so would this one be on the test? And then tries to read my face on whether or not it's actually on the test or not. So I don't know what's on the test. All right. I just said some person. Anyway, so that's the end for today. We'll do more graphing tomorrow.